Hello everyone, welcome to SREcon21 and thank you very much for coming to listen to my talk today on learning from complex systems. My name is Andrew Hatch and you can reach me on Twitter at Hatchman76. You can also check out some blogs I've written on Medium as well if you want to continue the conversation after this talk, because I would love to get some feedback and get your thoughts on this too. So, learning from complex systems. Complex systems, it's a big, heavy topic. And my intent of this talk is to give you, at least if I give you anything, I'll give you 4 takeaways to take home with you. And ultimately, I hope I increase enough of your knowledge or increase enough of your interest, and so that you want to explore this more as well, because this will certainly help us as we cope with greater complexity in our organizations. So takeaway number 1, in complex systems, we would call this emergent or novel events. In our industry, we tend to call them incidents. They're all pretty much the same kind of ballpark of things where things are happening that we don't normally expect, but they're really valuable because they really help us learn. So use them. Knowledge and understanding. That's how you learn. There are 2 distinct ways of doing it. We're going to explore this a little bit more because it's really important understanding complex systems, and we'll go over a bit of history of this as well. Also talk about how the people are the most adaptable parts of a complex system, especially when we're talking in technology companies. And we'll go into a little bit of that later. And we'll close it out with a quick sort of overview of how we, through this learning process, we can engineer more resilience into the systems that we build. So if you remember anything in this talk, I hope you remember these 4 things. So let's get started. So first of all, who am I? I'm from Australia originally. Been working in the tech industry over 20 years, spent a bit of time in my career in India, which was awesome, but I now work for LinkedIn as an SRE manager in the Bay Area. Outside of work, I'm a keen surfer because it's really complex, and I really like old Japanese cars because I find them just complicated and awesome. My career is spent mostly building digital products, either for mobiles or for the browser or the desktop, mostly writing code, but probably in the last 10 years or more, it's been around working in SRE teams, DevOps teams, all that kind of stuff, and mostly now being in management roles as well, which I really enjoy. My experience has spanned data centers, years spent in AWS. I have done a lot of incident commander roles for small scale incidents, few servers on fire, nothing too dramatic, through to large scale incidents which take entire sites offline. The reason I'm giving you this overview is because over the last 20 years, and I'm sure there are many of us listening today or in the industry which should also agree with this statement, is that everything is getting more complex. The systems we build are bigger. They have more moving parts. They deal with greater levels of complexity in the way we do things. And it's been how we've adapted over the 20 years of my career that I find the most fascinating. Because when I started out, linear models were pretty much the go. We did the waterfall model, which pretty much means we shipped giant chunks of code in stages. We do all the design up front. Then we do all the development, and then we do all the testing, and then we keep going back and redoing things all the time. And we ended up building huge siloed teams. Our releases were huge, which meant they were like a grenade going off, setting incidents on fire everywhere. And ultimately, we spent a heck of a lot of money doing this. And ultimately, the results were sort of getting to a point where we weren't really getting results. We were just spending a lot of money and just shipping really bad code. But we've seen this evolution over the past 20 years. And that is where we take the mantra that teams should own what they build, which means we try and do from an API first mindset. And we've seen this model proliferate where teams interchange information, and we're not trying to build the entire thing in one go. In other words, it's more reflective of nodes working in a network that are, to an extent, self-organizing. Now, for the complex systems theorist, this would be a no-brainer. This makes perfect sense. As systems get more complex, the only way to cope with that is to try and decentralize more. This is a common behavior both in the natural world and also in the synthetic world, the tech world that we work in. And it's driven by that mindset shift. As that realization comes through, that we move from the centralized command and control model of days of yore, and we move to this distributed model. We will still centralize things on security and budgets, and where we store our source code, that still makes sense. But as mentioned, we start to split this out. But as we decentralize and we get new incidents and novel events, that learning often is insulated within these distributed teams. So our knowledge of the complex system becomes more distributed as well, which is actually how we would want it. The challenge for a lot of organizations will still be where we want to centralize a lot of our incident response, especially when things go bad. But the reality is, how do we go back to that centralized model to understand what happened when all the knowledge has been distributed? So really, how do we learn as this complexity increases? One of the ways in which we can learn a lot about a complex system is when it does things we don't expect. And a challenge has been for us is that when we still follow that centralized model, we carry that baggage of learning along with us. And that baggage for traditional incident management kind of looks like this. Red flashing lights start happening because the site's not working, and customers call up customer service and they get very upset. This reaches management. Management has usual predictable responses to this. SREs running like firefighters or first responders put the fire out and then meter out punitive punishments for people who caused the problem. I'm probably being a little cheeky with some of my graphics here, but I reckon you get the point. And the reason why we created these processes is purely because we always carried the mindset that incidents were preventable. And that's because people just aren't doing what they're told. And if they were to do what they told, this prescriptive system we've built, then it would never fail, because surely we can totally control a complex evolving system in a traditional manner. And ultimately, it looked bad on management because it would people would perceive that management was not in control. So the only process really for learning from this was the traditional post-mortem, which generally became a rolling the proverbial downhill exercise. Many people would go in like this and leave like that, which means they wouldn't often disclose everything, or they'd be afraid to. And they would leave with some root cause action items that hopefully they will get around to prioritizing their product backlog, assuming that the product features don't get overruled for them. And we would interrogate people using these kinds of methods, like how could we not have noticed that? Why weren't you looking? Were you asleep? And how come the system didn't do this? This is how we designed it. This is how we expected it. It should behave in exactly the way we think it should behave. So a lot of hindsight bias tends to creep in. And ultimately, we tend to find that we want to blame the human. And so we use terms like human error, which I know a lot of companies still do. I would strongly encourage those of you who do to look at the origins of this term and perhaps maybe consider looking at things a different way. And is there a better way? Because we all know this, is that we're going to keep having incidents. Our complex systems that we build are going to keep surprising us in different ways. So maybe prevention isn't the best method, but maybe learning and adapting is. And not seeing the people and the system as two separate problems that need to be solved, but actually start looking at it as a wholly inclusive thing. The term often gets used as a socio-technical system, but you can think of that purely as just how does all this work together, and the interactions and behaviors between the people and the systems as the focal point. So why don't we look at it this way? We know this stuff exists. We see it everywhere. Well, the reality is it's like a lot of industries, even the complex systems we have, they have a history. And a lot of the history in the way in which we manage work has been driven out of late 19th century and early 20th century management practices. Now, I know Taylorism gets quite a lot of conferences. I'm not going to go into all of that. We can take away a few things. In the past, we saw people as cogs in a machine, and therefore we wanted to extract the maximum performance out of them at all times during the day. And because we didn't want them to sort of go off on their own and be too innovative, because they would exhibit these kinds of traits. And therefore we wanted management structures that were in place to enforce the rules that we have. Now, without going into the further dehumanizing aspects of Taylorism, I'll leave you with one thought on this, which I'll come back to. And that is this one right here, is that organizations were trying to maintain that relationship, that centralized mind of how I imagine everything should be done and how it is being done. And I want to keep that in sync. I want to have linked documentation, version controlled, code controlled, absolutely everything that links back so I can have complete traceability, almost like from a spider web going out. And so this worked pretty well in automobile manufacturing and other kinds of manufacturing. My grandparents worked in factories. They're used to this kind of thing. I didn't kind of get the irony that when I started out in my IT career as a software engineer, that I was also being measured by time and motion, Taylor study, lines of code per day, waterfall models, and of course, all these kind of crazy stage gating processes to deploy code. Highly inefficient. And it was inefficient because I was building software that was getting more complex and I was supporting it. And these linear thinking models or derived models of how to learn weren't working. And a large part of that was because of the way in which we were trying to learn when things were doing what we weren't expecting them to do, because we were seeing everything in chain of events theory. In other words, a one-to-one ratio between the cause and the effect of a problem. And ultimately, that's all it really was coming down to, was just that people weren't doing what they're told. And if we had expected, probably done what we're told, we would never have an incident. And where did all this come from? So I started thinking about this even more. And the reality is a lot of this is based on the way in which we saw our universe and our world for centuries. Now, this is no go at Sir Isaac Newton. This is simply just the way in which the world was perceived things. And we built lots of management structures around it, and the effect of them is still today. In other words, this chain and effect is what we call causal determinism in philosophical terms. And a way to diagnose things is by reductionism. That is simply just seeing absolutely everything, our entire universe, as something that could be broken down into irreducible parts, so therefore we could understand absolutely everything. We call this, in other terms, more acceptable term, is the billiard table theory, where no matter how I strike the cue ball, I can trace it back to a single event. What that really means is that absolutely anything possibly could be known by doing this reducible analysis and controlling the environment. And this was a prevailing wisdom for hundreds of years, is that the universe was thought to be almost like a hermetically sealed clock working in lockstep, and that we could completely understand absolutely everything about the known universe by following this method. Even time might possibly be could be reversible as well. But it started to fall short of how we learn in the future when we started looking at complex systems with the rise of thermodynamics and also social science 20th century. So we talked about learning. In the beginning, I spoke about knowledge and understanding. Now, knowledge is very much built on the linear analysis way of learning about things. It's just breaking things down. It's acquiring knowledge, and understanding is a bit more broader. And I'll give you a really simple example using a car. So assume you've just arrived on planet Earth and you've got your Newtonian mind well conditioned, and you're saying, please explain what a car is. So your first thing you're going to do is literally put it in a shop, pull out the tools and start pulling it apart. You'll work out quickly it's got a cooling system, forced induction, reciprocating piston engine, uses a battery, got lots of current, has some awesome carbon fiber disc brakes to stop it, and a transmission in which you can control. Now, by doing this reducible analysis, you will know everything about this car. You will know how it works. You will know that when you push a lever in the middle, the right to the back turn red. When you pull a stalk down on the left-hand side of the wheel, these lights start flashing around the car. But will you know why the light is orange? Do you know why the brake lights are red? Do you know why the steering wheel, if you're in the United States, is on the left-hand side, yet in the country where this car was made, it's actually on the right-hand side? There's actually an entire history around why steering wheels on cars are on the sides that they are, depending on the culture or the origins of that culture. You might also inquire to understand, why is the car called what it's called? It has badges on it. What is the origin of those badges and the tie back to the mark of the car that made it? It has a lot of safety features. Why does it have those safety features? Why are they there? What led the manufacturers of this vehicle to put these safety features in? Did they do it by choice, or were they forced to? It's got fuel saving. It's got energy efficiency in it. What are the driving forces behind that? Maybe there is this thing that burning fossil fuels might not be great for our environments. It's got some awesome four-wheel drive steering. Maybe that's the relationship. So all of a sudden, by looking more broadly, or applying the systems thinking, this broader mindset, and looking at all these different kinds of feedback loops that were going in to creating this car, we start to understand more broadly. But another key factor about this as well is that when we look at this car in the product of its environment, and when it's out literally on a road system governed by lots of signs, lots of lights, lots of directions, lots of implied rules, or even rules that, you know, cultures adapt to all the time, such as, why do cars flash their lights at you? Is it a warning? Is it saying, yeah, you can move over in front of me now, it's okay? Like, all of this is a big system that is enclosing other systems, that is enclosing other systems. And that's how you learn more about complex systems. It's by looking at these two different models of learning and combining them together. You need to do both, not just one. But often what we find in our tech industries is we tend to fall more on the knowledge side of learning and not so much on the understanding. When we start to understand that the universe is not a hermetically sealed clock in much the same way as the complex system we build isn't either, we refer to this as colloquially as tilting the pool table or pouring a bucket of water on it or hitting it with a chainsaw. But ultimately, understanding the effect of the environments is crucial. So we think about our work when we're either writing code, we're pushing code, we're under various pressures, on various influences on the way in which we should do things. Maybe we have certain deadlines, we have to work with different people in our teams. They're all complex relationships that need to be navigated. There is an overriding roadmap. We've got products running in production that has live users traffic, it has bot traffic. The system will respond and adapt all the time. In other words, understanding how environments impact a complex system is crucial because environments have a massive effect on governing how complex systems adapt and grow because of the environment. In other words, looking at what are all these influencing factors, the pressure on people, the expenditure, the growth of the systems, and learning how this happens. So, across systems and people as well. As mentioned earlier, we don't want to see these as separate entities. We want to see how the whole system evolves. Because one of the key drawbacks of just acquiring knowledge is we assume the environment is completely controlled. In other words, laboratory. But we now have production systems don't run in laboratories. At least out in production, they don't anyway. So, final example on this, where linear analysis breaks down. And now I'm going to actually draw in an example in text. So if we look at this graphic right now, you can think of all these green dots as nodes. They could be APIs, they could be databases, they could be systems that give different responses. This is simply just like any other chain of events that would happen in order to a customer pushing a button on your website or on their phone in order to initiate some kind of transaction. Now, knowing that in any day production, not everything is running perfectly, not everything is completely running at equilibrium. There's always different latencies, and sometimes these have effects on other systems as well that are consuming it. But ultimately, we've engineered this system well enough that it copes. But then sometimes through coincidence or the linking up of other events, more degradations happen. And these degradations start pushing more pressure onto the system. All of a sudden, we're starting to see that the system is starting to struggle under the weight of expectations. And ultimately, in the end, it leads to an incident. And all of a sudden, we're sprung into action. Now, if we follow the linear analysis path, reducible analysis or reductionism, or basically any term you want to throw it is, but ultimately is that we will start at the incident and work our way backwards. And we generally will be guided by the red dots in order to understand here is the root cause of the incident. Those observant among you might notice I did this 5 steps, and yes, this was sort of a cheeky throwaway to the 5 whys method of analysis itself, based on linear analysis techniques. The problem with doing this is that we're missing these other parts as well. And what could be worse in some organizations is that our recency bias may lead us to assume that when this happens again, we'll look there first. We'll start biasing our thinking towards this, and we could be missing other parts of it. In other words, we're not broadening our understanding. We're simply just trying to narrow down on the one thing and hopefully file that away and fix it and hope it never happens again. So, we've covered a lot of stuff here. I'm now going to give you some characteristics of complex systems, and then I'm going to ask you to think about this a bit more. So, probably already worked out by now, complex systems have lots of components, and small changes can have broad effects. They definitely embed in their environments, and they're sensitive to changes. They require constant energy. Basically, they never reach equilibrium, and hierarchy imposes constraints, and they have a history. So when I put these points up here, I put them for a specific reason, because they literally remind me of every single tech company I've ever worked for or software project. All of these characteristics are constantly in play, and they get amplified as those products and they grow and grow and grow. We know that through distributed or autonomous teams that we have more components that only interact locally. They don't have global effects. But local changes they may do could have unintended global effects through a chain of events that, or consumers that are using them. We know that they're sensitive to changes. We know that we build things for a certain traffic profiles and latency, but changes could potentially affect them. And therefore, also, we might need to expand out. Maybe there is more security requirements. You had to add in more code to support that. They definitely require constant energy and we never get to equilibrium. And entropy is always happening. We simply just cannot leave systems running for years and just assume they'll always grow and just be able to hand that growth without us constantly interacting with them. Hierarchy is always going to impose constraints. One of the drivers in our industry is always to put increasing layers of automation over things, which is great because it means there's potentially less manual processing, but every layer of automation is another layer on top of the complex system. And that's just the tech side. On the people side, as systems grow, we need more people to maintain them. We increase more hierarchy layers of management, but they also become way more abstracted. Think of whether your CEO in a large tech company could actually sit down and modify code and respond to an incident. Probably not. And that's perfectly okay. It's just needed to maintain this hierarchy. And lastly, they have a history. One of the first things you do when you onboard is learn about the origins of a lot of things and the way in which this company and the systems were built as they are today. So how do we learn better? So we've gone through different ways of learning. We've looked at characteristics of complex systems. We've understood the importance of incidents and how they are valuable. So how do we do this? Firstly, we need to stop saying terms like human error. We need to stop assuming that people are malicious actors who are trying to do a bad job, because they're not. We also need to learn not just from code and configuration, other things, but we need to also look at traffic. There's potentially malicious traffic, good or bad, whatever, we need to still do that too. And therefore, learning from how that affects problems and building out our knowledge and understanding of that becomes crucial, where we focus on contributing factors and not the root cause. We look at all the signals that are received and try and build timelines of events to understand all the different variations and permutations that affect both our people and our systems. And when we're running our incident post-mortems, don't just automatically assume that the engineer is the best person to do that. Often we'll be better placed, especially in large companies with big incidents or large effects of them, to think about creating dedicated teams where we actually have facilitators and we have scribes. And so we actually give all the participants time to speak, time for us to understand their view of the incident. What were they looking at? What signals they were getting? Not just focus on what they just did, but what led them to do what they did, and build that out and build more information around that and look for our patterns and themes. And if we do all of this a lot better, then we build greater knowledge of how our complex systems, emergent or novel events or incidents occur. We build greater empathy for the people who are actually on the front lines and supporting it, of which most of us who are SREs certainly can attest to. And we, through all this acquisition of knowledge, not only will we build better products because we're building better foundations on them, but we're building better tooling to support them as well, which actually helps our autonomous teams get better and take on more responsibilities. And lastly, through this acceptance, is that we start targeting these old haunted systems that everyone is afraid to touch and people run away the moment they're told to touch code to them. And instead, we're more comfortable and we're more confident in getting rid of them and removing them because we've built a greater amount of knowledge of how these old systems can have unintended effects globally when things go wrong to them. And to get to the last part, we will start to build more resilient systems and improve the ability to learn. And resiliency is really important because resiliency is everywhere, especially in nature. And a great example I often use is the Australian eucalypt or gum tree as is spoken in my native language. And that is that these are amazing organisms. They can survive the harsh climate of Australia, they can survive bushfires, they can survive floods, and they are still there. They have grown and adapted to the very complex system of climate and organisms of themselves, and they can survive this. We can only just look within. Our skeletons are amazingly resilient. We can train them to be stronger by lifting weights. Our skeletons can repair themselves. They do this all the time. And over millennia, we've learned how to take this innate resilience and engineer it. We've learned how to create splints all the way to modern day using surgical plates and screws to repair these things by amplifying and supporting those natural areas of resilience. So in our tech companies, we've just got to do the same thing. Learn more from complex systems, find innate areas of resilience and amplify them. Support the building of more resiliency into our systems so they're better able to adapt to the effects the changing environments will have on them, both for our people and our systems. And if we do all of this, our conditions for resiliency will be this. We'll learn more from incidents, and we will come to see them as normal part of complex system behavior. In other words, we'll just get used to the fact that we know these things are going to happen. We'll also, hopefully, should be well aware that we can't wait for this to evolve naturally. Yeah, it'll just happen. Just, no, it won't. Okay, it must become an ongoing practice. And ideally, we need to spend more time looking at how we can improve our ability to learn from complex system incidents in our organizations in order to create these kinds of conditions so we can sustain that capacity to adapt to change all the time wherever the work is being done. A key point, which I know you'll know from earlier. And also around socio-technical systems is that we'll understand those reactions between people and technology better. We'll think better about the way, especially as SREs, that we build the tools and foundations that we do. And we won't see these as separate challenges. And if we do all of that and we focus what we do well, we will sustain, nurture, and grow a learning culture in our companies. And with that, I would just like to say thank you very much for listening to my talk. I really hope you got something out of this. I really hope this will encourage you to learn more about complex systems theory. You can reach my talk at the URL down there at the bottom. I will leave that URL there for, I don't know, probably years. So feel free to grab that whenever you want. And as mentioned earlier as well, please reach out to me on Twitter and yeah, connect with me and please share your thoughts. Thank you very much. Have a wonderful day.